Hello, so today I'm going to be doing lab 2, the molar mass freezing point lab. And first, I'm going to start with my materials. I have the ring stand with the clamp. I have the paradichlorobenzene and the naphthalene. I have both of my size beakers, and I have my wide mouth test tube. And I also have my weigh boats and the scale, and then a cup of crushed ice. I'm gonna go over the pre-lab questions that I have done now. So the first question is, what is the formula and molar mass for the solvent, which is the paradichlorobenzene, and the formula is C6H4Cl2, and the molar mass is 147 grams over moles. And then I also have to do the formula and the molar mass for the solute, which is the naphthalene, and the formula is C10H8, and the molar mass is 128.1705 grams over moles. And then the normal melting freezing point for the solvent, I had to find that also, and that is 53.1 degrees Celsius. And then question 4 is, suppose the acid starts to freeze before you begin collecting the data. Explain what you should do to solve the problem. And I said, if the acid began to freeze before collecting the data, you would need to bring the acid back to a liquid and try again, or else you would not be able to find the data that you need. Question 5 is, what is the freezing point depression constant for the solvent being used? And I have negative 7.10 degrees Celsius. What should happen to the temperature of a substance while the substance is melting? The temperature of the substance melting stays the same. As the substance is heated, the extra heat increases the kinetic energy, and that causes the particles to move faster. And then number 7 was a math problem, so I will include a picture of this at the end. The purpose of this lab is to determine the freezing temperature of the solvent, the paradichlorobenzene, and I'm calculating the molecular weight and determining the freezing temperature of both the solute and the solvent, and I'm learning how to calculate the freezing point. So here I have my 6.5 grams of paradichlorobenzene, and I'm going to put this in the test tube and then move the test tube over the boiling water. I'm going to be recording the temperature every 60 seconds until it is completely melted. This is it beginning to melt, and it started melting instantly. So now I'm going to put it back in the water. So the results for the paradichlorobenzene I have in my experiment side of the notebook right now, and it took about 3 minutes to completely melt, and it melted at 53.66 degrees Celsius, but it started melting almost instantly at 48.67 degrees Celsius. So now I'm going to pack the 250 milliliter beaker with crushed ice. Now I'm going to place the melted solvent into the crushed ice and record the temperature of it turning back into a solid every 60 seconds. Here I have the solvent completely frozen. It took about under a minute to start freezing, and it was completely frozen at around 3.5 minutes, and the temperature was 26.5 degrees Celsius. Now for the paradichlorobenzene, the freezing results. It took about 4 minutes for it to completely freeze. It started at the temperature of 37.88 degrees Celsius, and it froze 4 minutes in at 26.55 degrees Celsius, but it started freezing within the first 30 seconds. So here I have my 1.5 grams of naphthalene, and I'm going to slowly pour this into my melted solvent that I have here. slowly pour and mix that. So then we can see what happens. And I'm gonna record the data of it. So I just poured a little bit. I'm gonna mix it up, see if anything starts happening. Right now it's kind of like the solute is on the top and the solvent is on the bottom, if you can see that. I'm gonna add the rest and see what happens. This is mixing. See how it is kind of separated? One's at the top, one's at the bottom. So I'm gonna keep mixing this to see what is going on. All right, it's all mixed now. So now I have the mixture in the hot water and I'm gonna record the temperature every 60 seconds until it's completely melted. The mixture started melting instantly and it only took like 2 minutes to fully melt. So now I'm gonna put it into the beaker of crushed ice and record every 60 seconds temperature until it is frozen or freezes. Here is the mixture completely frozen after putting it in the ice, and it started to freeze at about 100 seconds, like 34 degrees Celsius, and it was completely frozen around 3 minutes at 32.4 degrees Celsius. And then here I have the results for the mixture of the solute and the solvent. It took about 2 minutes for it to melt, and it melted at 59.27 degrees Celsius. And for the freezing, it took about 3 minutes for it to completely freeze. For the mixture, when we were freezing it, we started at 40.3 degrees Celsius, and within the first minute, it got to 39.05 degrees Celsius, and then another 60 seconds passed, and it was 35.9 degrees Celsius. And then the third minute is when it started to completely freeze, or it was completely frozen at 32.4 degrees Celsius. And it started freezing around in between 60 and 120 seconds at around 36.7 degrees Celsius is when it first began to freeze. So now I'm going to talk about the analysis. So the mass of the solvent is 6.53 grams. The mass of the solute is 1.52 grams. The experimental freezing point of solvent is 38 degrees Celsius. The experimental freezing point of the mixture was 39 degrees Celsius. The freezing point depression was 10.1 degrees Celsius. The molality is 1.42 moles. The moles of solute is 0.012. The molar mass of the solute was 163.44, and the active one was 128.17 grams over moles. The percent error was 27.5%. And then here is some of my work and the analysis page. And then I also included the cooling curve in Excel in the video that is about to show.